Hello, this is Aaron with iBoard Repair, and today I'll be working on an iPhone 14 Pro that was extremely smashed. It was run over by a car, so you can see a lot of damage on here. And the phone came to me without a screen. The screen was already removed, and the motherboard had already been worked on. So this went to another data recovery company or another board repair tech, and they were unable to solve the problem. And the phone appears not to turn on, but I believe it is actually turning on. I've done a little bit of diagnosis to this phone already, and let me show you why I think that. So here's the motherboard. It is the top layer of the iPhone 14 Pro here, so somebody's already split this away from the bottom layer, and they were working on this. And they did a lot of work to it already, and it wasn't necessarily the cleanest work. They dug around this screen connector here, so I do believe they came to the same conclusion as I, that this phone is turning on, but there's just no image on the device. I believe this is a no image case. They overheated the board a little bit, it appears to me, but it doesn't seem like it's too much of a problem. I don't like how they removed the shield because they were chipping the NAND here, but again, I think the NAND's probably fine. When I flipped this over, I did notice that this chip had already been reworked as well, and this is the image chip. I've gone ahead and removed this already since, but this was on the board when I first opened this up. I've removed it. So the first step I take when I'm working with a board that I don't know what's going on with is I take my DC power supply probes, and this is why I believe the phone is turning on, because of the sign that this will give me. I take my DC power supply probes, I touch them to the battery connector here, and I'll observe the amperage draw I get when I tell this phone to turn on by shorting the power button. I can short the power button right here, and we can see the amperage is giving what looks like a normal boot up sequence. So it doesn't look like it's turning off to me. It looks like it's staying on. And if I take my parts here and I plug them all in, this phone will still give me no image. So it doesn't look like it's doing anything, but according to my amperage draw, it is doing something. It's turning on. There's just nothing on the screen. Nothing on the screen at all. It's not giving any image. So the first thing I did when I'm working with a device that is no image, I guess I'll show you the no image first, just so we can see a before and after. So if I take a good screen, battery, and charge port, the top board alone should turn on. It would give me a 3-minute reboot without being connected to the bottom board, but that's fine. We're just testing to see if it turns on at all. And this screen is also shattered, but this screen actually still works. I use it for testing all the time. But when I tell this phone to turn on, we're going to see nothing. And I just want to show you the before and after, but if I plug this in, I'll get a normal amperage draw from my amp meter down here. It's giving me 1.2 amps of charging, and this is doing nothing. And that's to be expected. That image chip is already gone, but even before that image chip was gone, this phone was still giving me no image. And I do believe I figured out why, but first I want to tell you the steps I take when I'm dealing with no image. I'll do this basically every time. So basically what I've shown right now is what I do every time I'm working with a device is I'll take my DC power supply probes and I'll look at my amperage draw, and then that amperage draw will tell me what I'm going to be doing next. And in this case, what I did next was I went ahead and I tested the diode mode values of every single one of these pins here. And we can look at my multimeter here. It's in diode mode. And I went ahead and tested every single one of these pins here, and every single one of them gave me what looked like a normal reading. So that can throw you off a little bit. A lot of people think that if they have no image, then they must have a sign from their image connector here. And that is what the last tech kind of came to the conclusion of as well. You can tell because they removed all of the underfill away from all of these components, hoping to find something, but they didn't find anything. If we open our board view software on the iPhone 14 Pro Max, this is the connector, and when we zoom in, it will give us all of the values here. So OL, 0.45, this is ground, OL. I checked every one of these, and every one of them gave me the correct value. The next thing I checked was the image chip, and this is the image chip here. And like I said, this had already been replaced, so I just went ahead and removed it because I tend to just not trust the work of others. I don't know what they did. But if we zoom in here, we can also see this also gives us diode mode values. So before I went ahead and tried to replace this chip, I decided it's probably a smart idea just to check every single one of these values as well, because if anything's missing under here, then the chip will not work. If the chip does not work, that is the image chip, then the image will also not work on the screen. So that's the next thing I decided to check. And I was checking everything, and everything was appearing correct until we got down to here. These are just ground pads. That's what the 0.000 means. It's not ground like this because it's not directly connected to the rest of ground. And I noticed there's another one over here. This one did give me the ground reading. This one did not give me the ground reading. And if we look at what these lines are, these lines go through some big coils and they connect to ground on the other side. And like I said, that line was connecting to ground. This line was giving me an OL reading like this, which is basically not connected to anything. So this line is connected to this big coil. If I'm not getting the ground reading, that means that that line is not going through this coil and reaching ground, and that means that this coil is not connected fully. And that's where I'm at right now. I believe that I have a bad coil right here, or that if I push it really hard, it's going to fall right off. So that's where I'm at, and that's kind of the basic way you'll always want to check like a no image problem or any type of problem that's like isolated to one circuit. So I did see that he removed the shield here, and it kind of almost made me think that maybe he had came to that same conclusion, but I don't really think so because it doesn't really look like this area had been worked on. This flux is just left over from when they were working in this area. And I'll show you the readings that I got. So this one should be ground, and I'm getting that OL reading, the open loop. And this is the other one that's connected to that coil, to the other coil I mean, and this one is giving me the ground reading. So this line is connected to this coil, and this line is connected to this one. So let's give it a push and see if it falls off. Pretty interesting. It's not loose. So for whatever reason, this coil just lost continuity across it. So I still believe once I pull this off and replace it, I should most likely be fine. I guess there is also the possibility that somehow the trace that connects this line to this coil is broken, because I kind of expected this would push off. And you know, this phone had taken such a large impact. You can see how shattered it is. It's possible that there's like damage on in the layers itself. But one step at a time, I'll just go ahead and replace this first. And this should be a fairly short video, but it's always a, it's a good idea for you to know how to diagnose simple problems like no image. And in this case, it was as simple as making sure to check all the diode mode values that are available to us on ZXW. If you didn't have ZXW, you can always just take a donor board and compare readings to the donor as well. And that's another method I'll use if we don't have readings under or on a certain board. I'm quite surprised at how firmly this was attached. Oh no, there it goes. It was disconnected. So there we go. This was a broken coil here. So this should be pretty easy. Like I said, once this gets on here, this board should boot right up, and well, it's already booting, but it should give me image back. I might need a bigger iron to get this pad off, but let's see if I can get it off with this. I will still also have to replace that chip, and that will be the last step after this is replaced. And data recovery, or board work in general, can be very difficult if you don't know what you're doing, or it could be very fast and straightforward if you have a good idea of what you're looking for. Like, for all I know, the technician spent hours, like, working on this device and just was not able to solve it. And it's very common to go down a rabbit hole and just not be able to figure it out. So that's good enough. It's not perfect, but it will take a new coil just fine. And I have a donor board right here. So I'll just take the coil directly from here. This one already has a lot of, it's already been harvested and had a lot of work. So I have a lot of donor boards. It's always a good idea to just stock up on them. You can find them cheap if you look in the right spots. should be all it needs, and we can verify it's on there good by checking the diode mode value underneath that IC again, or on those pads. So now if I take my multimeter probes, I should no longer have OL on those on that line. I should now have what looks like ground. And there we go, we got a ground reading. That's what I was looking for. And this is the chip that was on there, and I could reball it, but it looks a little bit damaged to me. Does it? Maybe not so much. Right here, there's just the tiniest chips on the corner. It's not very much, but I'll just replace it either way. I'll just take this chip here, and I'll try to do a clean pull because I don't really feel like reballing this. If I could pull it clean, then I can just set it back down without doing a reball. I'm recording 2 videos today. I haven't been making very many videos lately, so I'm trying to get more recorded. So if I release another video close to this one, I have a bunch recorded, but depending on which order I edit and release them, you may see me in the same shirt in another video very soon. I know that doesn't really matter to anyone, but it will be a little bit hard to get a clean pull on this because I don't really have a gray area that I can put my tweezers. I'll just kind of overheat the board a bit and maybe I'll get lucky, but I might have to reball this. I think I'll just remove some of these chips. Alright, maybe now I'll be able to get a clean pull on here a little easier. I might still mess it up. It's sometimes hard to do. I moved it a little bit more than I wanted, but I do believe the balls are all going to be intact still. Yeah, that looks fine to me. I should be able to reuse it still without having to reball. And now once this chip is on here, we can test with our parts again and hopefully we'll see an Apple logo. It's a tiny bit crooked, but it should twitch into place when the solder melts. There we go. Looks like it moved into place. And we should be able to see an Apple logo now. So I'll grab my parts and let's see if it's turning on. Like I said before, the top board alone will boot up, but it will give us a 3-minute reboot. So we'll turn off every 3 minutes if it's not connected to the bottom board. But as long as it's turning on, I know this phone's going to be good to go. And as long as I don't run into any problems when I'm taking data, then this will be the end of the video once I confirm this. If I do run into like a 3-minute reboot from an unexpected problem, I'll turn the recording back on and address that, but I don't expect I will. And there we go, Apple logo. I can verify touch is working as well, I suppose. And it will also boot to the swipe up to upgrade screen if it's not connected to the bottom board because it can't communicate with the NFC chip. So that's all normal. It'll freeze here for a second before it goes there. There you go, swipe to recover. So if you were to swipe to recover, you can try to bypass the NFC problem, but it wouldn't work in this case because this will reboot in 3 minutes, which is not enough time for it to go through that next screen. So either way, this phone is going to be successful. I'll be able to recover data from it. I just need to put it into a jig with a good bottom board. And there are a few other things that could happen, like it could reject the passcode if I were to use a mismatched bottom board, so the non-native bottom board, and I don't move over the NFC chip. It does that sometimes, but it doesn't do that all the time. So most of the time, I will attempt to use a mismatched bottom board, especially because, in this case, I'll probably just try to use this one. It's not too damaged, so I can probably avoid that. But if I was missing too many pads, I would try to use a mismatched bottom board. I think in this case it will be fine to use the native bottom board. But yeah, that's how you would diagnose a no image problem on an iPhone 14 Pro Max. You check the connector first. If the connector looks good, you check the IC. If replacing the IC doesn't work, in an ideal situation, you'll want to have checked the diode mode values underneath the IC before you replace it. That way, that's what I did. I was able to see that there is a bad line underneath that IC before I went ahead and just tried to replace it. If I would have done that, it wouldn't have worked, and I may have been even more confused, and I would have had to do more work of taking off that IC again and trying to replace it again. So customer will be very happy that they'll have access to their data. So thanks for watching this video. Hope you learned something. Hope you stop by again. Bye-bye.